My real worry is the fires might shift that to savanna vegetation. It will never go back to being forest.
So we thought, well, this is something we can ask other people to do. We show people images taken from our satellite, and we just ask them to say if there's a cloud.
I was wandering around the jungle with a ladder, a bucket of nails, a tin of paint, and a tape measure, crucially, to measure the diameter of the trees.
Welcome to Emissions Impossible. I'm Kim McAllister.
And I am Hugh Mortimer.
Everybody get up.
Now, I am a broadcast journalist, but Hugh, you've got a much cooler title.
Well, I class myself as a space scientist. Now, I don't actually know whether that is a very definitive term, but it's something that captures the range of things that I get up to, because my main responsibility is building instruments to be sent into space that allow us to explore, effectively, the whole of the universe. But my main focus is really looking at Earth.
Okay. So when you're at a party and you go, "Hi, I'm Hugh and I'm a space scientist," what do people say to you?
Yeah, that's typically one of those things that you try and avoid telling the truth, I suppose. At parties, I think I tend to go for something like, I'm an airline pilot. Yes, I'm a trauma surgeon, because it's a little bit more kind of. It doesn't stop the conversation so quickly.
Try introducing yourself as a journalist. They tend to turn tail and run. Not at all. And I'm so excited to chat to you today because we are both, I would say, obsessed with space and satellites. What do you reckon?
I completely agree. I'm a proper nerd when it comes to space and science. And so I've got my perfect job. I've got my dream job. And, I don't like to tell my bosses this, but I would probably pay to do my job. So let's just leave it there before anybody takes my salary away.
Yeah, don't say that too loudly. We don't want you losing any money because you deserve every penny. And I love chatting to people like you because I'm a total space geek as well. I've made 3 series now about space and satellites, and I have just had my eyes opened to how exciting this whole industry is. And do you know what? Most people in the UK still don't know that there's a massive space industry in this country.
No, you're right. And I don't think people realise how much they are, you, me, everyone around us, is reliant on data from space. Things that are incredibly complicated, complex instruments that take a lot of, many years, up to 16 to 20 years to get into space. And we are reliant on it every single day. From, traveling to work and getting around the place through and using our GPS maps. That's all space enabled. From the weather and the weather forecast, all of that, we're very reliant on knowing that it's going to rain today. So all of that is also space enabled. But there's so many things that space offers. And hopefully we'll get to explore that today.
Yeah. And the one thing I want to say is you don't need to be an astronaut in Texas to be involved in the space industry, do you?
No, and actually in the UK, it's one of the biggest growing sectors. And not just space, but Earth observation is not just about the physics and engineering. Space is the biggest natural laboratory that we have. And it involves all sorts of disciplines, not just in the sciences, but, geologists are in there. You've got material designers, fashion, music. We're also looking at politics. All of that is incorporated into the things that we take for granted when we look up into space.
Yeah, and there's so much we could say, but in this particular episode, we're going to focus obviously on climate change, because that's the subject of the whole podcast series, and the role that satellites can play in not only measuring, but potentially preventing climate change catastrophes, right?
Yeah, and I think, again, one of the understated news stories is how much Earth observation using data from space has really enabled us to look and understand what impact humans are playing on the environment around us. And so ever since the first mission to space through Sputnik, we've had about 40, 50, 60 years of being able to take data and understand not just every year, but decadal long measurements of what is happening globally to our planet.
We can see forests disappearing, erosion on coastlines. We can see forest fires. We can see icebergs melting. These are all really difficult things to measure on the ground. So you really need to measure them from space, don't you?
You do, and if I wanted to measure something particularly accurately, I could send you out, Kim, with a thermometer to measure the sea surface temperature, but you could only measure that in one place. And then if I wanted you to do that all over the world, it would take you so long to get back to that original point.
It would be such a fun job, though.
It would. Well, if you like the sea and like traveling, it's brilliant. But we can do even better using satellites. We can get global observations and very high resolution as well of the entire Earth's surface within days. Just a few years ago, we would take weeks to be able to observe the entire planet. But now with multiple satellites, with the facilities that we've got in space, we can do that on a daily basis, and it's really improved our knowledge of climate change, weather forecasting, and actually what we're doing to our own planet.
And then holding people accountable. If we have these measurements, and you can't argue with data that's been corroborated and created by scientists, you give them to a government body, you go, this is what you're doing, and this is what you have been doing, and this is what you need to stop doing, right?
Absolutely. And that's the key link, is actually how do we turn the data, this raw data set that we got from space, to something that is actionable, something that policy makers can use to make informed decisions. And I think that's the biggest role that Earth observation now is playing, is providing the scientific evidence that we can use to make the changes that are necessary. And I'm really hoping that in this COP26 this year, that this is really going to be the time that we make that action as a human species to make those massive necessary changes.
Now, we mentioned Murray earlier. We have brought Murray onto this podcast. I've put him on the other side of the mic for once, which was hilarious for me because he and I normally co-host together. But we wanted Murray and his business partner Ed on because they have a really cool company, don't they?
They do. And actually, Murray is a kindred spirit. The marvelous Murray Collins is a kindred spirit when it comes to space science, because he's a space scientist at heart. But he's also somebody who goes out into the field, and that is something I also do. Not just sticking in a clean room, building instruments, or sitting in front of a computer processing data, but actually getting out into the field, into the forest, taking measurements on the ground, and that's really important to help us ground truth the data sets that we take from space. And Murray and Ed are two amazing people when it comes to this, because here in the UK and up in Scotland, a centre for Earth observation and climate change monitoring, they're doing a great job.
Here are Murray and Ed. So, Murray and Ed, welcome to the podcast.
Thank you very much. Good to see you.
This is funny being on the other side of the mic, isn't it?
It's slightly intimidating.
I'm on the same side of the mic as normal, so that's fine.
This is obviously about Earth observation, this podcast, something that you know a lot about. Pair of you, you've built a whole company around it. So for someone who doesn't understand what Earth observation is, Ed, how would you explain it?
It's a fancy name for satellite imaging, basically. So it's we have thousands of satellites orbiting the Earth, taking effectively photos of the Earth's surface all the time. There'll be some above us. We're on a lovely rooftop. There'll be some above us going over right now, hopefully taking photos, nice cloud-free photos of Edinburgh.
And why do we need these pictures from space, Murray?
Well, you all know, for instance, we have COP26 in Glasgow.
Yep.
The world's attention is focused more than ever before on climate change and also biodiversity loss. So we're fundamentally changing the composition of the atmosphere, and one of the major drivers of this is the way that we use land. And so we're clearing vast amounts of forest around the world. As a result, companies and governments are investing in what's called nature-based solutions to climate change, and broadly we're thinking about avoided deforestation here, so reducing that deforestation rate and in some cases replanting trees. In order to be able to decide where best to develop these projects and also monitor their success over time, you need consistent information provided on an annual basis over huge areas, and the only real practical way to do this is using satellites.
So you've built a company around this, but it's quite a new technology, or is it, Ed?
Satellites have been collecting data to be used to monitor deforestation since the 70s, but I guess the driver for our company is a deluge of free satellite data that started really in about 2009. So there's all this free satellite data daily observing the whole Earth that's available for companies like us to use. We all as taxpayers have funded it, and I guess Murray and I found slightly frustrating as researchers in the early 2010s that this data was around but not really being used to its full potential. We knew it could help save forests and plan mitigations and monitor, as Murray said, but maybe wasn't being done. So we launched the company to help use that data and hopefully save the planet.
Save the planet, because the forests are a huge part of climate change mitigation, aren't they? What role do they play?
Yeah, so about a third of the Earth's land surface is covered by forests. It used to be maybe twice that. So humans have, over the past 10,000 years, cut down a lot of forests for our agriculture, for our cities and so on. and we're carrying on doing that. We're losing forests in the tropics every year at a fastest rate we've ever done that. So that's responsible for about 20% of our emissions of carbon dioxide to the atmosphere, this continuing deforestation in the tropics.
Well, I do like to wind you up, Murray, and call you a tree hugger, but you don't mind really, do you?
I don't mind because it's the literal truth. When Ed and I first met, I was working in central Gabon, literally hugging thousands of trees as part of a forest carbon assessment. Ed was the rising star at this point, doing his PhD in Edinburgh, doing satellite data analytics, and I was wandering around the jungle with a ladder, a bucket of nails, a tin of paint, and getting my arms around this, and a tape measure, crucially, to measure the diameter of the trees, and from the diameter you can use allometric equations to estimate the volume of biomass in a stem, and from that the amount of carbon, and so you can extrapolate these relationships across the landscape and work out how much carbon you have stored in a forest. And then obviously as you get the change information, you can work out the emissions factor as well.
And you probably had to run away from quite a lot of elephants as well, didn't you?
Yeah, that was a interesting component of field work. Gabon's forests, well, at that point I think there still are good numbers of elephants there. They are not so keen on people walking through their forest, so they'll charge you quite regularly.
And you had to run off with a ladder over your shoulder?
Yes, I will admit to dumping the ladder occasionally when being charged by an elephant. Yeah.
And you're still in the field quite a lot, Ed, aren't you?
Less so due to the pandemic. But
well, before we were all confined to our houses.
Yeah, I've hugged tens of thousands of trees as well, so it's it's really important, we think, as remote sensing scientists, satellite imaging scientists, to actually go and see and visit and work with the thing you're looking at, because you get a weird different view from 700 kilometers away from an image, a kind of flat image from space. So it's nice to have proper what we call ground truth data to calibrate and validate what you're seeing. I mean, the power of satellite data is you can use these terabytes of data to map globally at high frequency, so every week or whatever, and have consistent measurements, apply the same algorithm in Colombia as in Indonesia. That's very powerful. But you might just be mapping nonsense. So we try to always make sure we've anchored something with real ground data, and the reports we do in space intelligence always go back to that fundamental property that you're trying to map.
Yeah. And it's interesting, I mean, it's easy for us to picture the satellites orbiting the Earth and taking pictures of the forests, but it's what you do with that data, because you're working with governments, you're measuring sustainable development goals. I mean, this is the big, exciting thing about Earth observation, isn't it, really?
It is, and there has to be a problem that you're trying to solve. I think it's very tempting again as scientists dealing with pretty data sets that we produce things that look great or we think are interesting but aren't actually useful to solve a problem a government or a company has now. I guess that's something again that the company helps us do, because we're working on contracts and solving problems and producing data sets that result in a change on the ground, and that's what's really exciting.
Yeah. And you, Murray, you had a stint at the university teaching. What excites students about Earth observation?
I think you'll find that most people in younger generations are fixated on the climate crisis, biodiversity loss, and want to do something about it. And satellite data, as Ed has eloquently described, is absolutely fundamental in assessing the state of the natural environment and enables people to develop projects which mitigates losses and can help restore our natural environment. So I think it's that application of the data to produce useful information that allows people to take action. That's what gets younger generations going, I think.
Yeah. And the other major issue, obviously, with forests across the world is forest fires. Now, I guess some forest fire is natural, but a lot of it isn't. Can you kind of explain the difference? Yeah,
I mean, this is one of the major current impacts of climate change we're seeing over this last decade. It's been in the news time and again all around the world that fires are happening at an unnatural level. So from boreal forests of Russia through Australia, through Brazil. Some of these vegetation types should burn occasionally. For example, savannas do burn, but we're also getting fires in areas that are not fire adapted at all. So fires going right into the Amazon, and boreal forests that are not fire adapted. And when you have those fires, they can cause a state shift, we'd say scientifically, so a change in the vegetation that won't necessarily go back to what it was. In climate change, we're making it less comfortable for many species to be where they are, and they can kind of have some resilience and survive that. So maybe tropical forests can survive in places that might be a bit too dry for it by kind of creating their own moisture. My real worry is the fires might shift that to savanna vegetation, it will never go back to being forest, never capture all that carbon again. So we're kind of exacerbating climate change through setting lots of fires. Most of these are human caused, and obviously doing deforestation, putting roads into forests makes them more likely. But also climate change, these big droughts we're having are making it more likely in general. And of course all these fires cause more carbon emissions, which cause more climate change, which means more fires in the future. So it's a bit of a vicious spiral that we have to reverse through.
We have to reverse it, don't we? And I really feel like Earth observation is the way that we can do that, because it's the only way to kind of force everybody to be held accountable at every level, right?
Absolutely. You can see the smoke and you can see the fires very clearly from satellite data. So that's why we're so much in the news, because it's so easy for people to map where the fires are. It's not just local communities reporting smoke or fires suddenly appearing. You've got these images showing massive islands of grease burning that are very easy to put in newspapers and talk about. So I think the satellite data is critical both for tracking the fires, but also provides data predicting where fires might happen. So you can see these dry areas. So these risk maps are really important in terms of mitigating fire risk or getting people out.
Got a question about disaster planning, so I'm going to go to you, Murray. It seems
That's kind of being thrown under the bus, is it, as my non-topic of area of expertise. But fundamentally, when you're thinking about how to manage a landscape, you need information which is accurate, timely and consistent. So if a hurricane passes through an area and you need an emergency response, you need to identify those areas which have been worst affected, where there's mass flooding, for instance. You need to prioritise what scant resources you may have, particularly in developing countries, to save as many lives as possible. And again, satellites are used in this context to understand where the damage has been most severe.
So it's, for a long time, satellites have been used immediately after a disaster. So they are tasked specially to go and look at a place immediately after a hurricane or an earthquake or something has happened, and that's very much part of the international response and very accepted. I'm actually more excited about using satellite data to try and warn about or prevent natural disasters, to see the landslip before it happens. The ground might shift a little bit, or to predict where flooding might happen, either stop it happening or at the very least get people out of the way. I think there's a lot more that could be done.
Dr. Murray Collins and Professor Ed Mitchard there chatting to me on a rooftop in sunny Edinburgh. Great guys, we had a really good laugh chatting.
They're wonderful, and I think it's really important to note what they were talking about in terms of forest and forest monitoring, that it's such a visual sign of climate change. I can't think of anything else that really represents the impact that climate change has and the struggles that we have as humanity in this idea that the forests that we live in and live with are changing so dramatically.
Yeah. And also, I want to bring at this point the UN Sustainable Development Goals, because these are obviously going to be a huge part of the discussions at COP26. There's 17 of them. I won't go into them in detail, but they cover all the elements of life on land, life at sea, poverty, all these kinds of things. And Earth observation really is key, isn't it, to measuring and monitoring most of these goals?
It is. So I was lucky enough to lead a UN SDG, UN Sustainable Development Goal activity with China. And our main role was using Earth observation data to help us improve farming and agriculture in China. So as you may or may not know, China is actually on official development assistance list that governments give money to. And you might think, oh, actually, China is a huge, amazing economy and it's growing really fast. But it's also got the world's biggest population. And so in actually working with Chinese scientists to help improve the agricultural productivity using Earth observation data, it was an incredible privilege. But as you say, Kim, Earth observation can really target almost every single UN SDG, from life on land through to climate change, through to helping food poverty. It is really critical and plays a vital role in being able to support all of those. So there is a UN program, Space for SDGs, that is being run, that is really critical to promoting how we can do that. I also want to highlight the fact that space is just one part of the solution in all of this, especially around climate. Climate is such a complex, intangible challenge that it's going to require a holistic approach. It's going to involve not just the scientists, it's going to involve the politicians, it's going to involve the general public. And so for people to become more aware, to make positive action and positive roles, it's going to take everybody.
And this would be a great point to bring in our next guest, Caroline Cox, who is a colleague of yours at the Science and Technology Facilities Council, because often with space and space technology, it can feel very, well, it literally is rocket science. You feel like you're just not clever enough to really follow what people are doing. At least that's how I feel when I speak to people like you. However, Caroline has got this awesome project which children can get involved in, or interested adults, to help classify clouds when it comes to satellite images. And I just love this project because it's such a great way of introducing Earth observation to someone who has no experience of that.
Absolutely. So I am honoured and privileged to say that I am a colleague of the amazing Dr. Caroline Cox, who works with me at the Rutherford Appleton Laboratory in RAL Space. And she works predominantly on measuring the properties of clouds. Now, as you can imagine, clouds can really and significantly impact the measurements that we take of the Earth's surface. If we get a cloud in the way, then it's very difficult to understand what's happening beneath that. And so that is why clouds are counted as one of the world's ECVs, essential climate variables. And that's just a fancy way of saying the properties of Earth that are really important to be able to measure and understand for us as scientists and as policymakers to be able to then turn that data into something that we know fundamentally about the world around us.
Amazing. And so cool that the STFC's funded something like this, because it just makes science more accessible, which can only be a good thing. So here's Caroline to explain more about this project.
So we wanted to make a project that was pretty simple, that perhaps primary age children can do and people can do with their families. We also wanted to show people all the beautiful satellite images that we record from space. Part of the job that I really like is looking at all the nice images of the Earth. So we sort of wanted to share that with people and get them involved in some of the science that we do, the climate science.
It's something I love to do. I've got two sons who are a bit crazy, but sometimes we lie on the trampoline and we just look up at the clouds and we find shapes and we talk about, so it's something that's a really nice thing to do with your family, isn't it?
Yes, yeah, it is. It's quite a nice thing to do. Yeah, people seem to have enjoyed it. The reason why we want people to do this is, as you may have heard previously, clouds can get in the way when we're making measurements of the Earth from space. So an important step in any sort of satellite instrument is to identify all the clouds in your image so they don't mess up the measurements that we're trying to make of the surface. So we're part of the team that helps look after a satellite instrument to check the data, to make sure it's right, monitor it, and that includes monitoring the cloud identification processes. We normally call this sort of cloud masking. It's a bit easier to say. But it's quite difficult to sort of monitor how well a cloud mask does because clouds are so variable, vary so much space to space. They, happen at all sorts of altitudes in the atmosphere. And one way at the moment that we can, monitor cloud masking is we get a scientist will sit there and they'll label individual pixels as cloudy or clear. As you can imagine, this takes someone quite a long time to do.
Doesn't sound like the best job in the lab.
I've personally never had the pleasure of doing that, but I know people who have. It is quite an arduous task. So we can't produce data sets like this very often and people don't do it routinely. So we thought, well, this is something we can ask other people to do. So we set up Cloud Catcher on the Zooniverse website. At the moment, it's not public, so you have to know the website to go to access it. It's still in beta test stage, but people can have a go at it if they want. Basically, we show people images taken from our satellite, and we just ask them to say if there's a cloud or if there's not a cloud present in a tiny bit of each image. That helps us, build up a data set of expertly classified data so that we can use it to compare with our satellite cloud masks.
That's fabulous. So even children, like my boys are 6 and 10, so they could sit and it would be a great game for them. Is there a cloud, is there not? And they click or they don't. And then they're, in their very small way, contributing to this wonderful piece of science which measures temperatures across the Earth's surface and helps us to combat climate change, right?
Yeah, that's right. Yes. So, in a very small way, we're sort of helping. And science is like a massive team of people doing, their only tiny little individual areas of study. But yeah, this is definitely going to be part of actual real science that people are doing.
That's so cool. This sounds like a great, very simple step that people can take to feel involved and to have a bit of fun along the way, right?
Yes, exactly. Yes, it is all about sort of involving people. So to date, we've had just over 1,000 people take part in Cloud Capture. So they've classified a few thousand images, I think, from what I remember. So we've checked the data that we've got, and we think it's quite a good way of using this to check our cloud masks. So we're hoping that we can take it forward and make it a public project and hopefully get even more people involved.
Has there ever been anything like this before?
There are other sort of cloud projects. So I think NASA did sort of like a similar, well, not a similar thing, but something related to people spotting clouds and feeding that into their analysis. There are lots of other Earth observation and other sciencey projects on the Zooniverse site. If people don't know about it, then they should check it out, because there's all sorts of different things you can do towards helping climate science. But we believe we're the only cloud masking thing on Zooniverse at the moment.
Brilliant. I love that, because actually you can see that inspiring kids to start to understand what Earth observation is and understanding the importance of satellites and, potentially pursuing a career in that area, right?
Yeah, exactly. Yeah. So if you look on our project site, then we also include a little bit of background information about, how we take the measurements from space and a few more sort of details about that sort of thing. So if someone was interested in working in Earth observation, then it's quite a good thing to check out to try and sort of understand the process a bit more. The data that we measure, obviously, it's really important data. So the satellite that we work on is called SLSTR. It measures surface temperatures of both the ocean and the land. It also measures fires. So all things which are really important to help us understand climate. It's really important for us to check the data that we're measuring is accurate and valid. Like, there are so many checks that go on in monitoring this data, because it's really important that this data is good.
I imagine it's a pretty big job over the UK, because I don't suppose you ever get a clear picture without a cloud in it, do you?
Yeah, very rarely, very rarely. I think at any one time, 70% of the Earth is covered in cloud.
This is so cool. I love the idea of us all being involved in this.
Yeah, we hope that people, do enjoy it and they have, come back to use it.
And this is a project which is led by the Science and Technology Facilities Council. So does it have a certain lifespan, or do you think it's going to continue?
Well, we need to seek some more funding to continue it. So we started off with a small grant from STFC, called the Spark Award, to get it started. And we're looking to get some more funding to take it into a bigger public project now that we've got, a bit of test data, now that we know that it works okay.
So you mentioned the measurements are about surface temperature and fires as well. Forest fires is probably the thing that people recognise, whether they have any expertise in this area or not, as a really major indicator of climate change. So how does a satellite measure a forest fire?
So in our instrument, we've got some special fire channels that are able to measure much hotter temperatures than other satellites can. So obviously when you've got a fire, the pixels are obviously very, very hot. So these special fire channels help us detect when there is a fire. It can work at all sorts of things, like the power that comes out of the fire, like the region, the space where the fire has spread. There's all sorts of things that you can do with the data.
And then what do you use that data for? Do you give it to governments? Do you give it to disaster relief funds?
So all sorts of scientists, either members of the public, can go and get this data. And I guess, yes, it might well feed into governments as well.
So how would a member of the public access that information? And what would they be seeing? Would it be a map? Would it be, a piece of programming? Would it be something they could understand?
Well, if they go to the ESA website, they can, in theory, use a little bit of software to download the images themselves and have a little look. But often, I think people don't know how to do that, because it's still quite technical. And that's partly why we set up Cloud Capture, because we wanted to bring these images to people in like a really easy way.
So yeah, as we were saying, if someone's interest is really sparked by this, you're the kind of gateway by classifying the clouds, and then they want to know more, then there is a lot of free resources out there. You mentioned the ESA website, the European Space Agency website. It's something that actually Murray wound me up about. He does satellite monitoring and creates maps and pretends he's very clever. But actually, I went onto the ESA website and I managed to download a map. And I managed to download maps from over a 10-year period of a place I know well, which is the Isle of Arran, just off the coast of Scotland. And I could see the difference in the landmass over those 10 years, you know, where the forests had been cut down or where the rivers had maybe slightly changed. And I thought, wow, I've got zero scientific knowledge and I managed to do this. So it can be done. You just need to know where to look. And it is fascinating.
Yeah, it is. Yeah, I love looking at satellite images from space. It's fascinating. And it would be good if more people could do it.
Dr. Caroline Cox there, and I found her really inspiring.
Which is why these STEM activities, these science, technology, engineering, mathematic activities that engage the general public are so important, because we need to bring the next generation of scientists through. Scientist isn't just a fuzzy-haired old man in a lab coat. It includes everybody, and we need everybody. Scientists need as many minds as possible to tackle some of these amazing challenges that we have. Her project, Cloudcatcher, being funded by the STFC, what an amazing project.
It's fab. And it is really important because Caroline and I mentioned, as you and I did, that there isn't a wide awareness of the space industry in the UK, which always makes me sad because it's such a brilliant industry. It's full of really passionate people. There, as you say, there's so many different elements to it. You don't need to be an astronaut. You don't even need to be a scientist to be involved. There's a lot of marketing and business and, you know, other elements to it as well. And I think projects like this just do a little bit more to make the general public go, oh, cool. And especially young people who are looking to A, make an impact when it comes to climate change, B, looking at the sustainable jobs of the future. I really feel like this is where they should be.
Yeah, and actually the space sector is growing much faster than the general economy. So at the moment they're suggesting 5% is the growth in the space sector, but we are understaffed in terms of skills. And as you rightly say, actually the new area of space is in the commercial side, because data is becoming freely available and processing data is kind of an online, potentially cloud activity now. People can set up space companies to deliver services to people who need them.
And I think it's a really positive story. You know, when climate change can be really overwhelming and people can just sit there worrying that there's too much to do and how much impact can one person really have. I think the story of space technology is really inspiring. And I think it's also a great way for people to get involved. As Caroline said, the information is all freely available. You just need to know where to look. If you go to the European Space Agency website, for example, you can find all sorts of land cover maps and do some digging and find out what's happened to your local area over the last 20 years. I find it totally fascinating. So yeah, it might not be recycling, reusing and all these other things that we associate with climate change, but it is a step that people can take if they're interested in being part of the solution.
Absolutely.
One step closer to making emissions impossible. Emissions Impossible is a Connect production for UK Research and Innovation. If you like what you hear, please hit subscribe.